Okay, so sometimes when you get square roots, you end up with a negative number inside. And mathematicians don't like that, so they made up something called an imaginary number. Now, an imaginary number is exactly what it sounds like. It's pretend, but we still have to learn about it. So, what they did was they called the square root of -1 I. I is the imaginary number. So, by definition, if you square I, you get -1. So, I equals the square root of -1, and I squared equals -1. So, if we think of square root of 25 equals 5, and then reducing radicals, so the square root of 200 is like saying the same thing as 100 times 2. And then the product rule, we can break that apart and say the square root of 100 times the square root of 2. The square root of 100 is 10. And then 2 doesn't have a square root. So 10 root 2 is the same as the square root of 200. If we typed those in a calculator, square root of 200, we would get this mess. And if we typed 10 times the square root of 2, we would get the same number. So it's the same idea with radicals. -49 is the same as -1 times 49. So we can break that apart. Square root of -1 times the square root of 49. By definition, the square root of -1 equals I. And the square root of 49 is 7. And then we write 7I. Because just like other variables, you write I right after the number. So that's how I works. Now, complex numbers are just numbers that combine real parts and imaginary parts. They look like this. So the first part is your real part. The second part is your imaginary part. Imaginary. So you could have plus an imaginary part or minus an imaginary part. That's just a complex number. A squared imaginary number produces a negative real number. So if you do 5I squared, it's like saying, because I squared is -1, it's like saying 5 times -1, which is -5. So 3I times 2I, 3 times 2 is 6. I times I is I squared, which is 6 times -1, or -6. That's what that's saying. We'll get more into that in a little bit. That's just what that means. Right now, we're just working on reducing some radicals. I don't know why it's giving me a hard time. So when you're reducing radicals, you're trying to come up with a perfect square that goes into it. So -24, well, that was not my intention. -24 is divisible by 4. So we have -1 times 4 times 6, which we can break into square root of -1, square root of 4, square root of 6. Square root of -1 is I. Square root of 4 is 2. 6 doesn't have a square root. And then we just rewrite it in the proper order, I guess. So 2I would be how we would write that the quote-unquote right way. And then the 6 stays inside the square root. So why don't you pause the video and try this one. So -300 could be -1 times 100 times 3, which breaks into root -1, root 100, root 3, which would be I, 10, and root 3. And then our quote-unquote proper math order would be 10I radical 3. So there you go. When we graph complex numbers, Look, it looks, we call this the complex plane. Instead of x-axis and y-axis, we have the real axis and the imaginary axis. So instead of the x and the y, we think of the x like the real part and the y like the imaginary part. So negative 2 plus 3i would be like graphing negative 2, comma 3. 3 minus 4i would be like graphing 3, negative 4. 4 plus 2i would be like graphing 4, comma 2. And 4 minus 3i would be like graphing 4, negative 3. So if we call these A, B, C, D, we'd graph them just like regular points. So we'd go negative 2 on the real part, up 3 on the imaginary part, that's A. 3 on the real part, down 4 on the imaginary part, that's B. And then 4 on the real part, up 2 on the imaginary part, that's C. 4 on the real part, down 3 on the imaginary part, that's D. 4, 3, yep, that's D. So why don't you pause the video and try to plot these two? So this would be 3, comma negative 4. 1, 2, 3. And this would be negative 4, negative 1. Should be right there. All right. Adding and subtracting. For the purposes of doing operations, you treat I just like a variable. So you combine like terms. So 3 minus 4i plus 2 plus 5i, you combine like terms. So 3 plus 2 is 5. And negative 4i plus 5i would be 1i or I. So 5 plus I. When you're subtracting, I recommend doing what we did when we were subtracting polynomials and carry that negative sign through. Then negative 5 plus 11 is 6. And 7i plus negative 2i is 5i. You try that one. 3, carry our sign. 3 plus negative 2 is 1. Negative 4 plus negative 5 is negative 9. Okay. Multiplying. If it looks like A here, it's just distributive property. So you distribute it. 4 times 5 is 20. And 4 times negative 2 is negative 8i. So it's no different than a variable. When they look like B, we're going to FOIL it, just like we would a regular binomial. So first times first, outside times outside, inside times inside, last times last. Now here, we're going to simplify that I squared. So remember, I squared is the same as negative 1. And 9 times negative 1 is negative 9. So this I squared, what it's really doing is it's pretty much canceling it out and changing the sign. That's my shortcut. And then you're combining like terms. So 8 plus negative 9 is negative 1. And 12i plus 6i is 18i. So why don't you pause the video and try those two? All right. 1/2 times 5 is 5 halves. And 1/2 times negative 2 is negative 1. Or just I. And then when we FOIL, first times first, outside times outside, inside times inside, last times last. And then you can either do it out like I did up there and say negative 12 times negative 1 is positive 12. Or you can use the shortcut where it cancels out and changes the sign. 6 plus 12 is 18. 9i minus 8i is 1i. So there are your operations, adding, subtracting, and multiplying. Your other complex operation is dividing. So before we can do anything, we find the complex conjugate. So if you remember, your conjugate is where you change the sign of the second part. So for your complex conjugate, you only change the sign of the imaginary part. So for a here, the imaginary part is the I root 5, so the plus becomes a minus. So remember, we did this with the radicals when we were trying to rationalize the denominator. So this time, instead of changing the radical, we're just changing the imaginary part. So here, when all we have is imaginary, that just becomes positive. So instead of negative 1/2 I, it becomes positive 1/2 I. So let's add this. What if it was 4? 4 is a real number. So the imaginary part is like 0. So the complex conjugate is still 4. You just don't change anything because the imaginary part's still 0. So pause the video and try that one. So it just becomes negative 3 plus 4i. All right. So when you divide, it's just like when we were rationalizing the denominator. You're going to make a fraction of the conjugate over itself and then FOIL. So instead of 4 minus I, I'm going to multiply by 4 plus I over 4 plus I. And then I FOIL the top and the bottom. So 2 times 4 is 8. 2 times I is 2i. 5i times 4 is 20i. 5i times I is 5i squared. And on the bottom, I do the same thing. 4 times 4 is 16. 4 times I is 4i. Negative I times 4 is negative 4i. And negative I times I is negative I squared. Now I'm going to simplify. So my I squareds are going to change the sign. And so this negative I squared is like saying negative times negative 1. So it really just becomes positive 1 is what that ends up being. So now I combine my like terms. So 8 minus 5 is 3. And 2i plus 20i is 22i. On the bottom, 16 plus 1 is 17. And these middle terms will always cancel out. Reduce if you can. Otherwise, you're just left with 3 plus 22i over 17. All right, so why don't you pause the video and try this one? Our conjugate is going to be 5 minus 2i over 5 minus 2i. So then I FOIL. 3 times 5 is 15. 3 times negative 2i is negative 6i. Negative 2i times 5 is negative 10i. And then negative 2i times negative 2i is positive 4i squared. On the bottom, 5 times 5 is 25. Then we have minus 10i, positive 10i, minus 4i squared. Our I squareds are going to change the signs. 15 minus 4 is 11. Negative 6i minus 10i is negative 16i squared. 25 plus 4 is 29. The 10i's cancel. I don't know why I put I squared there. That should just be regular I. And then nothing simplifies, so that's our answer. Fun story. You can do these on the calculator. Right now, if you enter I, or if you were to do that on a calculator, you'd probably get error non-real number. So we're going to change the mode on your calculator. So there's a mode button right next to second. So right next to the blue button, there's a mode button. If you hit that, you're going to get all these menus. So if you go down to where it says real and choose the A plus BI option, so click that and hit enter. Now your calculator will allow the use of I. So if then hit second, which is the blue button, and then mode again, it'll take you back to the main screen. To get I, hit second, which is the blue button, and then the decimal point, and you can type I. So try typing I to the 35th. So second decimal point, and then the caret, which is up above the division, 35. It gives you this really, yours might just say negative I, or it'll say like this really big thing. It's like saying 0 minus I is really what it's saying. Depends on how well your calculator processes the 0. Some of them are weird. But you also can type this. So you could do parentheses, 3 minus 2I divided by, don't forget the parentheses, 5 plus 2I, second I. And it'll give you a mess, right? But then there's this fun button. If you hit math, which is right under the green button, and then you hit enter, it's saying, hey, put my answer as a fraction. And then you hit enter again. You get 11 over 29 minus 16 over 29I. So the calculator will do all of this math for you. So that is one thing. So but doing it by hand sometimes is simpler, but sometimes you have the calculator. The problem with the calculator is you're often going to get messy answers like this. So you have to be ready for how to convert that. If you do it by hand, you get the fractions. So that's your choice. The last piece is this simplifying piece. Simplifying I. Powers of I. So I will always fall into a pattern. It will always reduce to either I, negative I, 1, or negative 1. No matter what the exponent is, it will always reduce to one of those four, no matter what it is. Now, in the calculator, sometimes it'll look like it did up here, where it's that really like blah, 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 E negative 15. And it's just because it's a calculator, for whatever reason, it's not human and it doesn't recognize, like E negative 15 is scientific notation saying it's 0.15 zeros and then 3919. It's 0. It's just not recognizing for whatever reason, then it's 0. So if you see that, like anything E negative 15 and then minus I, that's really negative I. It could show up where it's saying like negative 1 and then it might say like minus 3.19 E negative 15I. That's saying negative 1. Whenever you see this E negative something, it's really saying 1. But these are the four things that you'll see. So if you typed I to the 18th, this is really negative 1. If I did I to the 252nd, it's 1. If I did I to the 2547th, I get that big long thing again and then minus I. So that's really negative I. So you can just stick those right in the calculator and it'll do it for you. So that is what you need to know about 2-4 with your complex numbers. Let me know if you have any questions.